So yeah, I was asked to say a bit about actually, I was asked a bit if I could say something about DQMH because I've been working with that. And then I was like, yeah, I can do that. What I'm doing with the DQMH mainly is that we're building a hardware abstraction layer, or HAL. So that went into the title, that it's a building HAL with DQMH. Short background, that's me, Martin Lentz. I've been working with test measurement since '99, together with some of the guys that were in the corner here, back in the Nokia days. Been doing LabVIEW since '07, test stand since '09. I've been a certified LabVIEW architect since '14. Also used to be a test stand certified developer, and currently I'm with the Kongsberg Defense and Aerospace, just outside Oslo, in Norway. But today I'm here. A little bit of background about what we are doing when I work in production test, and what we are testing or what we're producing are these weapon stations. And what we are mainly testing is the electronics that are inside the control systems for them. The weapon stations are placed on top of vehicles or ships or whatever. And I think probably not Sweden, but all of the other countries here have them in their defenses and forces. When I joined Kongsberg 4 or 5 years ago, in production test, we had a test solution where we had a 19-inch rack with, I should not stand and point with my hand because the guys online can't see it. We have a standard test station that is a 19-inch rack filled with different instruments, and with a hardware test interface. For testing our UUTs, we built some test adapters that are mainly splitting out from the Mac panel interface to different other cables that can talk to the UUTs, and then we have, of course, a unit on test that is being tested, and we have some software running the test. The old system that was being used when I joined was very tightly coupled to the existing hardware, which is a problem when off-the-shelf instruments go obsolete and you want to continue test with the same software. So we found out that we had a quite inflexible and not very scalable solution. Everything was built already then on the NI platform, so it's test stand and LabVIEW. But yeah, in a quite inflexible way. So why change that? Well, we needed to do an evolution of our test platform to get new instruments in, and also to make some other adjustments to it. As I said, instrument obsolescence is a problem when your system is inflexible. And then we had a general wish to make a more flexible software architecture in the system, where we also could use a higher degree of reusability when we was switching from project to project. So this is where we thought out the hardware abstraction layer that we were going to implement. We came up with this three-layered architecture, where we, on the bottom, we have a object-oriented driver structure built in LabVIEW, which is supplying us with a flexible, scalable design. where you can easily swap between different drivers. The middle layer, which is what we are getting to in a while, is a DQMH layer. DQMH is short for the Delacorte Qt Message Handler, and is one of the architectures or frameworks that are being used quite a lot worldwide at the moment, and have been for quite some years now. We use the DQMH for getting a clean API to our hardware abstraction layer, and it also comes with a built-in test interface, which is nudging us to be better at testing our software, which we of course should be even better at than we are. And then on top of that, we have made a test stand wrapper around the API, because we have a group of test developers that are not all architects and do not all understand a lot of LabVIEW, but are quite good at test stand. So when we gave them a test stand sequence, they easily incorporate that in their test programs instead of having to figure out what we want them to do with the LabVIEW API. So the test stand wrapper is quite optional, but in there for convenience for some of my colleagues. As I said, the bottom layer is a object-oriented structure. We have a parent class, which is a general instrument class, where we put in everything that we think is general for more or less all instruments that we could think of. So as we see here on the left, it's can get the part numbers that are in the system. We can open the instrument, conduct a connection to the instrument. We can close a connection. We can set the address of the instrument and stuff like that. Inheriting from that are classes of the different types of instruments that are in the system. So shown here is the power supply class, where we put in all the extra stuff that we believe that power supplies need. And inheriting from that, we have a set of classes for the specific power supplies or specific types of specific instruments that we use of every type. So that could be, now I'm saying Agilent, now probably, yeah, HP, Agilent, Keysight, whatever names they want to use. It could be an NI power supply, for instance. It could be whatever. The whole API, the whole object-oriented structure is using a factory architecture pattern to make it easy to swap between different drivers. And it provides a quite flexible and scalable base for us to work on. And as I have mentioned here in the bottom, this is not something I thought out myself. It was based on examples that Chris Roebuck made for Delacorte for quite a few years ago. But took that idea and framed it around it. Now we'll skip the middle layer for just a second and go directly to the top test stand layer. As I said, it's a framework, it's a wrapper. It's for creating Lego blocks for developers that might not be that experienced in the LabVIEW part of it. Yeah, it's built on the API, and we have split it into a few different sequence files, mainly to make something that is more open for the developers to use, and something that is more hidden. And since test stand do not offer what's called access scoping, so you can't set things private or public in test stand, we split it out in a file called private, so people at least can see, okay, that's the private part. Don't start messing with it. It's doesn't provide a lot of security, of course, but We work with the tools that we have. We have integrated into our own in-house process model in test stand, so that the system can automatically initiate the drivers when it starts up. And then in the middle, we have all the cream. As with any layered cake, the good thing is the middle. So the DQMH part is our API or middle layer. It supplies us with a quite clean architecture on top of our OOP drivers, and then it has this built-in software test functionality. For those that do not already or are not already familiar with the DQMH, just going to step through a bit of presentation of that. It's an architecture framework developed by Delacour. The name Fabiola de la Cueva might ring a bell with some people, might not. Some years ago, they handed it over to a consortium, the DQMH consortium, that is now owning and maintaining it, and it's backed by some of the major players in the LabVIEW environment, and also a network of trusted advisors if people need some help. There's a lot of scripting in there that allows us to focus on the fun part, which is developing useful content. And it's based on a queued message handler pattern, but using events, user events for messaging between the different parts. So a basic queued message handler would probably use a text string or stuff like that, but here it's event driven. There's a range of different third-party tools that supports it. There are some dashboards for debugging, and there's also the anti-doc, which I would like to point out, which is an automatic documentation tool of your code that Lab has developed, and it helps me a lot, at least. Takes a lot of work away from having to do documentation, which is not so fun. Then I will do there's a lot of windows open here. Let's not attend that. A quick and dirty presentation of DQMH. So installing the DQMH framework, you do that from the VI package manager. And when you don't do that, you'll get this little extra line here when you're opening starting up a project. So you can start up a DQMH project. You'll need to give it a name, and you'll need to put it in some location. Put it here. Let's call it demo. Then it'll do a bit of scripting in the background. A quite short time. It will give you a project. Now, since I didn't plug my PC in, it's clearly on eco mode, so it's not so bad. No problem.
Yeah.
So just go down here and say speed up.
Have to sacrifice a bit into the demo guards.
Yeah,
Yeah.
exactly. There we go. So it has built a lot of different things here that we don't need to really think too much about. The interesting parts are the main VI for each library that has built, and the tester. So yeah, as I said, a lot of scripting, which is building all of these VIs and libraries and stuff. But I guess an empty DQMH project is not so fun for people to have a look at. So let's just go to the next little demonstration, which is actually, if I just jump over and get my PowerPoint. Oops. Slightly faster. So, I made prepared a demo here for the power supply class of our hardware abstraction layer. So this is the test interface that we have. You get a standard test interface from DQMH, and we have expanded it a bit to be able to test the different parts that we have in our driver. And in here you can say run a new instance of the driver, and tell it to show the front panel of that specific driver that you're running now, and then we'll just go and select class, and I have made a simulated instrument class here for test and debug purposes. Then we don't need to give it a visa address because it's simulated. And then I connect it to the instrument, and see on the front panel that it say that it's running the simulated class, and the little simulated button down here lit up together with the connection button. Then we can go and we can say, well, we need 12 volts on this power supply, and we need to put a power limit of 2 amps. Would like to switch it on. Like to measure how much current we are drawing. Right now we're drawing 1 amp on the simulated power supply. We can ask it, is the output state on or off? It says it's on. Now it says it's off. And we can go and do other stuff that we have put in to our specific need. We can read out the current limit that has been set. We can read out the actual voltage and the set point of the voltage. And read out the part numbers that we have in our system for this driver. Since we're in defense, everything has a part number and is very released fixed thing. We can read out the last calibration date if the instrument knows it. Apparently it was today that was calibrated. And we can read out model numbers and serial numbers from the instruments, of course, provided that the instrument has that data in it. And run a self-test and ask if it's simulated or not, and read the error information from an instrument. But what's more fun is that we have built this as a clonable module, so we can actually spawn an extra power supply if we needed it. We, for instance, had 2 power supplies in our system. Then we can go in and up here we can control whether it's all the clones we are controlling, or whether it's clone 1 or clone 2. So I can connect to clone number 2. Hopefully. Oh no! Now, of course, since it's a presentation, there's something that was failing. Let's try again, spawning 2 new ones. Oh, here. Both of them are simulated. Both of them connected. Yes. I forgot to choose the class of the second one before I tried to connect to it. Then, yeah, we're putting in, for instance, 12 volt again on number 1, and 2 amps. Then put in on the other one. We can say, okay, for this one we need 24 volts, and maybe 5 amps. Then we can go up here, say all, and we switch on the output state for both of them. See that they are controlled simultaneously. And we can read back the current that is on one of them and the current that is on the other one. And yeah. So that's what we've done with our hardware abstraction layer. Now, I didn't check the time, so I don't know if we have time to go into the code.
Yes, we have.
It's always time to go into the code. So, as I said, the main VI is the really interesting one. You'll recognize the front panel from the little demo before. On the inside, this is what all the basic DQMH modules look like. There's a event handler on top and message handler on the bottom. So all events come into the event handler, and when are being handled by the standard event handler, and then they're being put on a queue with text strings, and then the message handler on the bottom is handling all the different cases that all the different message case for every message that can be sent into the system. So, for instance, if we want to open the yeah. If we want to set the, then not set the class, which one should we take? We can take the reset. So when, actually, yeah, that's mine. Now my phone is ringing now. So, yeah. Great presentation. When you set up your class, as I said, it's a factory pattern, which looks like this, which means that we have a standard power supply class that is going in, and then it's being overridden by it's inside here. It'll pick up the class that it'll pick up the class that the name of the class that's been sent in, and it'll pass out the class to that it needs, which is then being put back into as a PSO as a power supply class, and then all the other, and that is then being kept up here in the VI data line that that you have inside the main VI. And for all the stuff that that's going on, we just pull out the class and call the method that we need. And then, since it's object oriented and it already has the right class, it'll know which instance of the instrument class that it needs to pick up.
Before you go out,
yeah,
can I just add quickly?
Sure.
So one of my colleagues told me about a new feature in LabVIEW 2024 or 25, where if you right-click the string at going into the case structure in the bottom loop, you can do a history probe, and then you get the same view as you had with from the DQMH module. Then you get a listed number of messages coming in through this wire with the history and the order that they came in.
Okay.
Which is very useful for debugging acute message handlers or similar. Mm-hmm. So that's a new thing they added in probes, which is quite good.
Cool. I did not know that.
Oh. But I have one.
Yeah.
If for people who don't have seen DQMH before, then I think it's very interesting to see how easy it is to create a new message. Because it seems quite complex what you've done there, but actually most of the code is done by DQMH.
Yes. I mean, all the, if I can open that little demo project before, and then can show how much code is actually recent project. Because if you go in and look at this, then as you see, all the skeleton is or type framework is being built by scripting. So that was what I created before without doing anything, but else than saying that it should just create it. And yeah, I don't want to go into all our classes today, because then people will see that this has been built in a fairly old version, 2018. So there's no interfaces, there's no all the fancy stuff that you can do with classes now, which would have been nice if we started the project today or a few years ago when that came. So.
But you have time to say something about how you debug these when you're running the dynamically loaded classes?
When you're
You're dynamically loading the actual pass by pass.
Yeah.
So if you want to go all the way down to the bottom and start debugging them and put the codes and stuff in there, where you end up.
Sure. Go back to here. Then actually, if we start up the tester again, and it's quite easy to go and there's also a button here saying show block diagram for troubleshooting. So it'll pop up the block diagram. And for instance, if we want to go to the one where we set the class, can say a breakpoint here if you want. And then we can go in here and say I want to fill up this one, then it should have stopped. It did. Thought it would stop there. Why didn't it do that? Okay. Oh, it did. Not maybe. No, it didn't. Anyway, but you can pop up the block diagram for every clone and see that and do all your debugging there and follow the lines and set probes and directly on each clone.
Yeah.
And also if you then, of course, since it's since it uses the method calls here, you can then if you are debugging, then you can go and dive directly. You can break it on that method call and step into, and then you will dig down into the class, for instance.
Okay. Do you need to have that actual class that you're loading in the project, or does it appear?
No, you don't need to have it.
As long as.
Actually, our project, I don't have the classes in that project. I only have the DQMH API in this project. Mm-hmm. We did that because of our release regime, which made it easier to release all the different instrument classes on their own. So we don't have to make a new release of the API when we change something in some small bug in one of the instruments. But that's mainly because of the bureaucracy at Kongsberg. You could also easily put it into the project, and but you don't have to. And also the test interface can also be used as a debug window when you run from test stand. Then all the I can point up there. Then all the messages, the debug messages, will still pop up here.
They can actually see you through the camera, so it's okay.
Oh yeah, okay, through the camera.
Yeah,
they can,
yeah.
True. But yeah, all the debug messages will also pop up on the tester if you open that next beside your test stand. So when we're using it from test stand, that gives us a lot of debug information. Yeah, that's.
There's a question from the chat. If is DQMH updated with interfaces in the newest version?
DQMH does not use classes at all. So it is just that we have used classes below DQMH. But DQMH is not a object-oriented as such. But it of course supports whatever you do with your objects.
Yeah. I hope it was enough for Bjarne, else please write or say something again. But it is, as I see, the classes below the classes in the lower layer you are calling.
Yep.
Where you wanted interfaces.
Yep.
Yeah.
It would.
Can you comment on how you're documenting you use this anti-doc tool? Is it good? I mean, there's a lot of events going on, and it can be very overwhelming to follow all the activity.
The anti-doc anti-doc toolkit or plugin or extension or whatever is you give it the project, and it'll run through and take out, look at all the different events names, and it documents all of the events are lying here. What did I open? This was so all the event handling is happening in event calling or whatever is collected here in the public API folder, and in DQMH they're called requests, and so every method that we have in our lower lying classes we have made. And we have made a method for that, and we have made a call for the event call for that. So the anti-doc will run through all of those and list them in the documentation with the inputs, outputs. It also goes down and looks at the classes and gives you all the methods and how the inheritance and can show you afterwards a document that I have. I don't want to try to dig it out right now, but I can show you how it looks like.
So it's actually useful.
It's very useful. I find it very useful, definitely. And it of course is only as useful as the document or the things that you put in. It'll give you the names of the VIs, and it'll give you the inputs and outputs, and it'll give you the documentation that you have put into the VI. It cannot do, it's not AI, so it can't go and analyze the code. So it's only as good as the comments that you put into your code.
There was a question from the chat about DQMH is still developed and new versions. And there was also answered, yes, it is. And then there was some question about the link it is in the chat to DQMH, also the consortium. And if you have a look about who is behind DQMH consortium now, it's some names that if you look a little around in the LabVIEW community, you will see them everywhere. They are very active, both DQMH, it's very developed.
They're quite heavyweight people.
Yes, just from the chat.
But yeah, that's more or less what I had. I think I had many more slides. No. So thank you.
There have been some talk about DQMH here today, and how many have tried it? How many have used it? There's one using there, one using there, and of course, no, you have also tried it. Yes, I'm happy you also say. But I thought maybe because both of our presenters have talked about it, then I would just show, or maybe together, maybe you will come with some inputs with DQMH, how to start with it, because it sounds as you saw all this code on Martin's presentation. Seems very, very big. Like what is actually requiring to start up using it. I have made a project, so it's not taking so long. It is exactly the same as Martin was doing in his presentation, just a great project. And when you have this, the singleton module, it is one that can only run one time. It is the simple one. You can just call the module, and it's only existing one place. The clonable, it is, for example, when you have the power supply, you want to have more power supplies, then you can spin up more modules. But in very simple, we can just start with a singleton. As you saw there, it is the basic. I'll just install it. Just created a new project. There's nothing I have done else until now.
Unless you're not sharing.
I'm not sharing.
Well,
No, I'm sharing the wrong.
You might be sharing the wrong.
Yes, I'm sharing the wrong screen. Stop share, and then we will pull this one over here. Thank you for that. And then we will try and share the right screen. Now there's a corner around this one here. Yes. And we can then open the front panel as Martin was also showing. And we can then send a message, and it's doing something, and it's coming. It's doing something else I was sending, but we can see a message here. If you want to do something, if you then want to implement a new function, we just stop the module, stop this one here, or implement a new message. Wanna, for example, init a power supply or something like that. We can just go in and create a new message, DQMH event, or create a new event and create a new DQMH event. Then I would suggest that we just take the singleton module that you're setting up, which module it is. It is just sending, you can hear, we can maybe take that later, it's just sending a one-way message to this module. Then you can set up some different, then we can have a name, it's, we can toggle a LED, and then we will maybe add a LED as input. That is the data contained in the message. So now here we actually just want to toggle a LED on the front panel of the module. And then suddenly DQMH have put a lot of extra code in. It have this toggle LED we can see in the tester. There will come one here where we can send the up here where we can send it. But then it's also broken. You need to put a little code in yourself. You need to put this in the right position. You can see what is actually broken. It is saying it needs an input here for a toggle LED. Yeah, it's sending it. It was actually more if we set true constant. If we set true constant here. We can also set that to just set this one. This is then the data we are sending together with it, toggle LED, and then we can send either a true and a false. It was the data we decided to send in. Send there, and then if we go over in our module that we saw before, the singleton module, there is also a little code needed. There is here, it have also made everything around. So we just need, we have a Boolean here. So we can maybe set up, we have a LED here, round LED. We call it LED and we make it a little bigger. It's not the best to sit so much around there. And it's just a new installation, so I haven't turned off this here. And then we are just taking create local variables, and then we are saying change to read, and then we are saying and then we are saying so if we, and then we can just have a case structure here. And so therefore, if we set that to true, we are toggling the LED. So if the message coming in is true, then we are toggling it. If it's not, then we are not.
Probably needs to run a wait function. Otherwise, it would be toggling at 60 reps.
No, because it will only toggle when we send an event. So it will only be, we can then go back to the tester. We can say start tester. We can start the module. We can show front panel. And you can see if my small virtual machine here is, then we can say send the event toggle LED, nothing happens. We can then say if you actually want to toggle it, then it's toggling. It could also be turn on the power supply or initialize or anything like that. That's the only code. That's only the code you actually want to care about. You need to do here. Everything around that is scripting. Of course, if you want to change a lot, then you can have some issues, but there's a lot of tools for that. If we are going back to stop module, then we can say rate. Yeah, we just take I think some time, then we take a new one, and then we say we need to save them, because else it's not. Yeah, it needs to be saved before the scripting tools, everything is going in. We are going in the singleton module, and then we will actually want to have a request and wait for reply. We have some, maybe we want to make some numeric function, some calculation. We call it calculation. It's requesting and waiting for a reply. And over here, we are then saying we are taking a numeric again. So we are doing some calculation in behind. We call it calc. We just, then again, it's doing everything for us. And we can see up here, there's this wrong one. Yes, it is right one. It is wrong one. It is this one there I would like to first. In the tester, we take this one just here. And we are taking the calculation, and then we have an input. And we have an indicator here. So we have an input. And we have an indicator. And of course, we also need to do some calculation. I don't know what we actually want to do, but it's in here. And then we can say, okay, we actually just want reciproc. Just add that one. Then we can also add some arrows. We either need to, because when it's have a reply, that could also take some arrows. We are just taking a constant there, and then we can see what is then also missing. No, yeah, of course. Yes, it's always when you're doing a reply, it's always setting this one here, so you are sure that you're doing something. Now it is. It's like breaking the code, tell you where it is. It's the way that the DQMH is doing it. And we can then start it. This is the tester. So when you're testing all you have, you can then say you want to have 10, and then you say calculate. I need to start the module. Very good. And then you need to calculate, and it's 0.1. Then you can test all your single modules in that way here. If we stop module again, we can then in the application down here, I actually have a question to you, Martin. Mm-hmm. From DQMH basic, there is like the tester is separated from the library. You are like pulling them in, so you have them included. Is that right?
Yeah, we
have them inside the library here.
We just like to have them next to it.
Okay. Yeah.
Yeah. We put them in the same.
Okay.
We get an error if the input is 0.
I don't get an error. I get a nan. I'm not quite sure.
Yeah.
Because the function is getting another number. Yeah. I could then add this or add another but it's infinity. Yeah. I could of course add it, but it's not in here. Yes. And you're actually getting an application where you have all these things here inside the application, and then you can add. Then if you wanna, you can just take do something. Actually, if you add an extra button we can just do it here. We can just do it here if we say like OK button. If we say that one here and say toggle, have the toggle up here, and then we are just adding an event case for a new toggle on here. Add it. And we then need to pull in the event you have from the toggle. You can just do it from over here, then you are sure where it is. You can just call this one here. Oh, yes. And there you have it here. We just take this one in there. And take the toggle in. We just take the toggle in there. We just say we always want a toggle. And of course, you need to have started your module. So if you start from scratch, you need all these here register events. So first time you do it, it's a good idea to use the one here. And then in initialize, you need to, or in connect to modules, you need to, you need to start them here. Yes, start by instances. You need to start the different module, start of the module, and then, but everything is in there. And then what have I? That was the tunnel. Yes, it is. What I should do next, because then we will just have it. Wait for event again. You can also make some extra, like in a normal state machine. And then you can start it, and then you can see it's shown when you're starting it, and then hopefully when we add toggle here, it's toggling. And that, of course, you can, like everything else, you can mess up with DQMH, but I actually think it's enforced you a little to do some simple structures, and it's quite easy to get started with for projects. I don't know what you two can say how to get started and to get used to it. What are your experience?
Well, first step is to understand the cube message handler, what that is and how it works. Then there's a number of video tutorials online, and that's one of the reasons why we have chosen it, because there is a forum, there is a widely spread, and there's really, really good tutorials on how to use it.
Yeah.
And that lowers the threshold so much to understand this this framework. So that's why we've chosen it. It has drawbacks. One of the drawbacks being that in the main functions of each module, there's a lot of administration to go around, and there's just this small part in the middle where you actually implement your intelligence in the system. And quite early on, once you put that into subgroups of AIs or create classes, that's a different thing. So, but as long as you're fine with the idea of spawning a lot of different processes that you send messages to and get them back, gets answers back from that, and you're fine with that padding on programming, DQMH is great. We also looked at Active Framework, which is similar in its heart, to be honest, but the threshold there is just too abstract for more junior developers to grasp it. So we ditched that and went for this. There we need to do something again now and then. Yes, we can mess up. There's nothing enforcing any good structure of your modules here that you have in Active Framework that we need to enforce a tree structure of your modules. Have one module there, and it's dependent on two others there. Just can't start creating dependency in the other direction or to anything else in your dependency tree that enforces a tree structure. That's not happening here. You need to do that. So sure that you don't mess up. But yeah, I like the the level of complexity that they reached here. They kept it simple. Whatever's in complex in there, they've hidden it or kind of made that for you in the framework itself. So once you start seeing the code and just not seeing all the administration around it and seeing like this is where I work and it's really good. You need to get past that. Once you get past that, that's good.
Yeah, it was the exact same ideas that we went for DQMH and not Actor Framework, because I did not see many of my colleagues understanding Actor Framework. And yeah, you have the problem that you don't have a lot of real estate to work with. Some of it, and also quite often you'll need to add a third loop, which I think with the newer versions than the one I'm using actually has built-in capability for adding a helper loop. Yeah. But I haven't tested that out on now.
Can some of you comment on your experience using the tools to navigate such a system? I mean, this is Panther Lab. Anybody who used that?
I haven't tried it. I've only seen it since I've been stuck with the LabVIEW 2018 until a couple of months ago. Yeah, well, we do production tests, and it's what's running in production. You don't change it.
Yeah, no, I haven't experience with that. So I heard about it first time today, so I'd like to come and check it out. We do use anti-doc quite a lot to just map out how the modules talk to each other, and then in that we kind of see we break the tree structure. Something I miss the kind of enforcing tree structure. It's too easy to create. Not spaghetti code in this way. It's kind of spaghetti architecture.
Well, it's LabVIEW.
Spaghetti anyway.
Organized.
Yeah.
But their Panda lab have a very good viewer to all your libraries and classes, so you can see if there is mutual, if they're calling each other. I don't remember what it's called, but it's giving a very simple overview. He's sitting in Mexico. Is it Javier? Enrique, it is Enrique, yeah. Who is doing that. I've seen him playing with Panther.
Is it trusted advice?
Yeah.
It's actually making GDEP on South America.
Yes.
Students project. So the fourth GDEP on one.
I've also only seen the Panther dashboard, but I saw him present it, and I don't know why I haven't started to use it, because it's really, you had the overview about which module you had and which one was running, and you can open them. So yeah.
Yeah, because that's also one of the caveats that you might have some clones that you forgot to close.
Yeah. Yes.
There's also a bunch of kind of do's and don'ts when you do call your own API or your own ask yourself what is 1 plus 1 for that, and that this one or two pitfalls there.
But if you ask Fabiola about the starting with DQMH, I asked her, and she said, don't take a whole project, take a small part of a project, make a DQMH module, then call it from there. Then you will see how it works, because it's working very well with other code. Of course, you need some of the one from the application, like starting the module, but it's actually not so much you start to add in. Then you can have one module if you have a project. You can, of course, also in a small project start it, but it's also very good just to have one place, one module.